Today's topic is client-server computing. So before we define what client-server computing is, let us look at the historic development up to the stage when we have client-server computing today. In the 1960s and 70s, when computers were used, computing was mainly based on mainframes. Data and software are located in one place, and we had one monolithic operating system to take care of the computing. In the research in the 1980s led to some development in the 1990s. So we have in 1960s and 70s computing based on mainframes. Data and software were located in one single machine. The 1990s saw the development of fast local area and wide area networks. Fast local area networks and fast wide area networks. There was a large-scale development of personal computers. And this means that computing in the 1990s have been built on the following components: personal computers, fast networks, and distributed operating systems. Also distributed application software. And in this context, client-server model has been used. With the advent of distributed computing systems, the client-server model has been developed to develop application as well as system software on a distributed computing system. Now we will look at some of the issues which led to the client-server model. The model of distributed computing which came into being from 80s to the 90s, they created the possibility of sharing information and also sharing of peripheral resources. So the characteristics of distributed computing systems are as follows. We have distributed hardware and software. We have distributed systems, both hardware and software. We have distributed application. And we have distributed data. A distributed system should support certain things in order that they can be useful. Number one, it should support distribution transparency. So that the fact that data and software are not located at a single place does not hamper the programmer or the software system developer. Secondly, it must provide an efficient inter-process communication facility. provide an efficient inter-process communication facility. And thirdly, it must be integrated into one virtual system. Subject to these conditions, distributed computing environments have many advantages. Firstly, we have improved performance. And that improved performance can come partly from the parallel execution. In a distributed computing setting, we can have parallel execution of programs which gives us improved performance. Secondly, availability and reliability improves. This is because we have distribution of different components to different systems, as well as replication of data as well as software, which gives rise to reliability as well as availability. Thirdly, resource sharing can be practiced. So if we have one single resource, for example, if we have a printer, that printer can be shared by different client systems. So this is an example of resource sharing. Fourthly, it is economical to have a distributed system because of all these reasons. And fourthly is the issue of scalability. We can keep on adding number of systems and the system is completely scalable. However, there are certain problems and certain challenges which have to be solved in order to make distributed computing system more attractive. So challenges are to get a good model of distributed computing. Secondly, we must provide transparency. Transparency in all forms: hardware transparency, data location transparency, service transparency, etc., so that the programmer or the developer does not face unnecessary hurdles in trying to write the programs. So we have a method to provide transparencies. Hardware transparency, then we'll have service and data location transparency, thirdly we have data replication transparency. Also, the problems of security and authentication need to be solved whenever we have distributed systems. Now, let us look at the simple model of client-server computing in a distributed system. So first, let us present the very simple model of such a system. We have a client process here, a client system, and we have a server system here. And the client sends a request to the server. And the server responds to the client's request. This is the basic model of a client-server system, and there are many applications, common applications of client-server systems that many of you will come across or you're already familiar with. For example, many services are provided as client-server services, like example, printing, electronic mail. Then we have file servers, which provide file service. We have servers for naming, the domain name server. We have servers for authentication. Then we have database service. We have database servers. We have computing servers. So what we have shown here is the logical model of a client-server system. But in practice, a client-server system will be implemented on a physical computer, and we will look at a possible implementation of such a logical model. We have a client process here. And the client process and server process, which are sitting on two different computers, in practice cannot directly communicate without going through the operating system or the communication facility. So this is what takes place in reality. This is the client process here, and this is the server process here. And we have a three-layer system here. So client process is in top of the operating system, which is on the top of the, below the operating system is the communication facility. Similarly, for this machine, we have the OS layer and we have the communication facility layer. And this denotes the physical communication channel. This is the physical communication channel. Now, when a client process sends a request to the server process, the request passes through the operating system layer of the client machine, passes through the communication facility, and goes through this physical communication link and is transmitted to the server process through its communication facility, through its operating system layer. So this is the request message. The response message comes from the server process through its OS and communication facility layers and reaches the client process through its communication facility layer and the OS layer. So this is actually the network or the communication facility. So this is the actual physical implementation of the client-server model, which we logically represented in the diagram earlier. So before we proceed further, let us give certain definitions about what is a service, what is a client, and what is a server. Before we come to client-server definition, let us understand the meaning of service. A service is a software entity. And the service, this entity, the software entity, runs on one or more machines and provides an abstraction of a set of well-defined operations. A service is a set of well-defined operations which is provided by running on one or more machines. So a service is a software entity that runs on one or more machines and it provides an abstraction of a set of well-defined operations. Now we are ready to give the definitions of the client and the server. First, we give the definition of a server. A server is an instance of a particular service which is running on a single machine. So a service can be running on one or more machines. A server is a single machine which runs an instance of a particular service. A server is an instance of a particular service running on a single machine. Now, what is a client? A client is also a software entity, but it is a software entity that exploits the services provided by the servers. A client may interface directly with a human user, but it need not. Also, typically a client and a server system reside on different machines, but it doesn't have to be that. We could have a client and a server both residing on the same machine as a special case. Now, let us look at the features of the client-server model. First, it is simple, it is modular, it is extendable, and it is flexible. However, there are some major problems with the client-server model, and we must be aware of those problems. Firstly, a server is very critical to the client-server model, and a server failure may affect the service. A server failure may affect the service. This is because the control of individual resources is centralized in a single server. So if that server fails, there will be a lot of problem. Secondly, each server is a potential bottleneck. Each server can be connected to a large number of client machines, and it may provide a bottleneck to the client systems. Thirdly, there is a cost and reliability trade-off involved. You can have multiple servers with multiple implementations of the same function. This will naturally improve the reliability of the system, but it will also increase the cost. So there is always a cost versus reliability trade-off involved. Now, how do a client and a server cooperate? Suppose these are the different client computers. These are user process. This is client computer 1. This is client computer 2. And we have client computer N, each having user processes. And then we have one single server computer. And let us say we take an example of a server computer which is a printer server. This server computer is a printer server, and they communicate through this network. Now, different client computers may send different requests to the server computer. For example, maybe client computer 1 is sending request to the server computer. Also, client computer N can send a request to the server computer. So at any point, at any time, a number of client computers can send requests to the client computer. So this is a model of a single server. There are different models of client-server computers. This model where there is a single server and many clients, this is called the single server model. So single server model is the simplest model, and it was the first model to be introduced. But now other types of models of client-server computing have come up. For example, we have a chain-based servers model. Where there is a chain of server computers. There is a computer, the client computer sends a request to a server computer, which in order to satisfy that request, it may need a service from another server computer. So the first server computer acts as a client to the second server computer, and it sends a request which is serviced by the second server computer, comes back to the first server computer, which satisfies the first service and sends the response back to the client computer. So let us illustrate this process by a diagram. So we have the user process here. Suppose we have two server computers. One is a file server. So this is a file server. And we have another authentication server. Now the user computer, the client computer sends request 1 to the file server computer. This is a request for a file. In order to handle this request, this server computer wants to know whether this particular user is authorized to use that file or to read that file. So it sends a message or another request to the authentication computer. It sends request 2 to the authentication server. The authentication server responds to this with response 2. And the file server, on getting that response, carries out the service and sends a response back to the first computer. Okay. So this is the client computer. This is the first server computer, and this is the second server computer. And this is a model of the chain-based server model. Thirdly, we have a multiple server model. In the multiple server model, we have a number of servers, and we can have parallel execution of programs on a cluster of servers. So this is typified by often in the computing environment. Now often we have a cluster of workstations, and we can have parallel execution of programs on this cluster of workstations, or the network of workstations, which it is sometimes called. So in multiple server model, we have parallel execution of programs on a cluster of workstations. Secondly, we have distributed databases. Thirdly, we have cooperative work groups. And fourthly, since we have a number of servers, we can have a service multiplication. So we have service multiplication. And service multiplication leads to increased performance, also it can be used to improve reliability as well as availability. So we see that distributed computing systems, which started with a basic one-to-one client-server model, has moved on to one-to-many client-server models, where there are many servers, and also to chain models in order to improve performance and reliability. Because if we have a single server, that server can prove to be a bottleneck, and if that server fails, then the entire system will fail. Now, when we have slightly more complicated systems, this communication does not take place directly between the client process and the server process, and we can have indirect client-server cooperation through the presence of what we call agents. So let us look at that. We have indirect client-server cooperation. So we have a client process here and a server process here. And attached to the client process is an agent. Attached to the server process is another agent. And there is communication between the server and the agent, and between the client process and the agent. These agents communicate with each other. So the agent with the client process sends a request to the agent associated with the server process, and the agent with the server process sends back a response to the agent with the client process. The role of agents can be different. It can be either simple. The agents can have a simple role in a simple communication module. So agents can act as a simple communication module. So advantage of using agents here is that the agents hide the communication network details from the client or the server. Or we can have agents can act in a more complex role as a mediator between the client and server. In this capacity, the agent may have several roles: heterogeneity resolution, so it makes the process smooth. The client and server doesn't have to bother about this heterogeneity. The agents can also do resource managing, as well as servers cooperation. Now, we will give an example of an architecture of client-server system, which is the three-tiered architecture. The three-tier client-server architecture, as the name suggests, have three tiers: the client tier, the application tier, and the backend tier. So the client tier provides the user interface and presentation processing. the application tier provides computation and function processing, and the backend tier provides data access processing. So number one, we have user interface and presentation processing. Which is the client tier. This is responsible for accepting inputs and presenting the results. Second, we have the application tier, which deals with computation and functional processing. We have computational and function processing. Through the application tier. And this tier is responsible for providing transparent, reliable, secure, and efficient distributed computing. It's responsible for providing transparent, reliable, secure, and efficient distributed computing. And also for performing some necessary processing to solve a particular application problem. Thirdly, we have the backend tier or the data access processing. This is responsible for accessing the data stored on storage devices. Accessing data stored on external storage devices. Now, let us look at an example of the three-tier configuration. So we will have three tiers. So the first tier is the client computer, which provides the user interface. This is the client computer, and it provides the user interface. Secondly, we have the server computer. It provides the computational function. And thirdly, we have the data server computer. Data server computer, which provides data access. And we have a communication network here to which they communicate. So this is an example of a three-tier configuration. Now, when we have a client-server system, when we have one or more servers, so one of the tasks which is involved, this involves is service discovery. Our client must know both whether there is a server which provides the service, and if there is a server, it must know the location of the server in order to access that server. So client must know whether there is a server which is able to provide this service. And if the server is present, its characteristics, name and location of the server. So service discovery can be achieved in different modes, in one of the following modes. Firstly, the address of the server computer can be hardwired into the client computer. Service discovery can be achieved in one of these ways. Number one, the computer address or the number is hard-coded into the client computer. Computer address hard-coded into the client computer. Secondly, broadcast can be used to locate the servers. Thirdly, so broadcast means that suppose the client and the server computers are also attached to the network, and the client wants to find the server which provides the service. So it broadcasts the service on the network, and if there is a server computer on the network which can provide the service, it responds, it takes up the request and responds to the request, or the server computer lets the client computer know that it can provide that service. Thirdly, server location lookup can be performed via a name server. Fourthly, there may be a broker-based location lookup. So there may be a broker agent which can aid in discovering the server. So having looked at this introduction to the client-server model, we now will look at communication between clients and servers, how clients and servers communicate with each other. The communication between clients and server must be fast. That is the first requirement. So unless the communication is fast, the user will not get a feeling that he is getting the service immediately. So what we really want to create is for the user a feeling that he is sitting in front of a very powerful computer, and which is being able to process its requests. We want to make it transparent to the user. We want to make the user unaware of the details of the communication taking place across the network. So in order to do that, we must look at the factors. So first, let us look at the factors which influence the speed of communication. So factors influencing performance of a communication facility. Firstly, the speed of a communication network. So the speed of the communication network is very important. The communication network may have speed of megabytes, order of megabytes per second, or even the very fast networks today have the speed of the order of gigabytes per second. Secondly, so other than the speed, there are some other factors which influence this. The communication protocol is one of the factors. There are connection-oriented protocols like the OSI or TCP, which require a lot of overhead, so which might slow down the communication speed. But there can be specialized fast protocols which provide faster communication, especially across a WAN. So whether it is a connection-oriented protocol like OSI or TCP versus specialized fast protocols. Thirdly, the communication paradigm is important. Communication paradigm or the communication model which supports the cooperation between clients and servers, and then OS support provided to deal with the cooperation. So we must look into the. There are two communication patterns. It can be either one-to-one or one-to-many. Communication patterns. Communication may be one-to-one or one-to-many or group communication. And secondly, we look at some inter-process communication mechanisms. There are two important inter-process communication mechanisms. One is message passing and two is remote procedural calls. So we will look at the details of both these communication paradigms, message passing and remote procedural calls. Today, we start with message passing. Message passing is a paradigm where the user is aware of the message used in the communication. The message is visible to the user, and the user is also aware of the mechanisms used to deliver and receive messages. What is a message? A message, we have already looked at the meaning of messages when we looked at object-oriented systems. So a message is a collection of. So in this context, a message will be a collection of data objects which consist of a fixed size header. So since a message is going to be passed through a network, the message has to be recognized as a message. So the message will have a fixed size header. And it will have a variable length body because the contents of different messages will be different. And a message is managed by a process. And the message is to be delivered to a destination. There are two basic message passing primitives. Number one is send and number two is receive. So send has the syntax send destination, source, buffer. The execution of this primitive send, which has 3 parameters, the execution of this primitive sends the message which is stored in buffer to a server process named destination. The message stored in buffer is sent to a server process whose name is destination, and the message contains the name of a client process named source, which is to be used by the server process to send a response back. The message in the buffer is to be sent to the destination by the source, and the reason why the source is to be sent is because the server process, destination server, has to reply to this message, and it has to reply to source. The second primitive is receive. We have receive client buffer. The execution of this receive primitive causes the receiving server process to be blocked until a message arrives. The server process specifies by providing the client name of a process from whom the message is desired. So server is waiting for a message from client, and it provides a buffer to store the incoming message. We will stop here today. In the next class, we will look at various types of messages, and then we will move on to the other form of inter-process communication, which is through our remote procedure call, or RPC. We stop here. Thank you.